This is problem 7-85 from section 7.1.5. Find the equation for the inverse of the function f of x equals 2 times the square root of x minus 3 divided by 4 plus 1. Sketch the graph of both the original and the inverse. So we know to find the inverse of our equation, we're going to switch the x and y. So this is really y, right? So we're going to switch those x and y values in the equation. So I'm really going to have x equals 2 times the square root of y minus 3, that divided by 4, with a little plus 1 on the end. Right? And I'm going to solve this for y. I'm going to get y by itself. So first thing I need to do is I'm going to subtract 1 from both sides. Okay. So I have x minus 1 equals 2 times square root of y minus 3 over 4. Next step is to get my radical sign by itself. I'm going to have to divide by 2 to cancel this out. So I need to divide by 2. Right? So my next line will say x minus 1 divided by 2 equals the square root of y minus 3 over 4. Now to cancel out my square root sign, I'm going to square both sides. They're the opposite. They're undoing each other. That's what inverses do. So this square root and this 2 cancel each other out. So now I am left with x minus 1 squared over 2 squared. Right? Each individual thing is squared. Equals, no more radical sign, over 4, y minus 3 divided by 4. Again, I'm trying to get y by itself. So the next thing I'm going to do is multiply by 4. I'm undoing the dividing by 4, so I multiply this outside by 4. Now, what is 2 squared? Look at this denominator right here. 2 squared is worth 4. So if I'm multiplying by 4 and dividing by 4, really those are going to cancel each other out as well. Okay, so they canceled each other out over here, but since they happen to both be the same value divided by each other, they cancel out. So I'm really left with x minus 1, that quantity is squared, equals y minus 3. Last step is I add 3 to both sides. So my new equation, this is the inverse equation, is going to be x minus 1 quantity squared plus 3. And that is my inverse equation. It's helpful to write it in either what we might call something as inverse notation, is if I wrote this as f inverse of x, because that was how it was written originally. You can say y inverse is also the same thing too, but when we say function notation, that means this guy over here. Okay, so that is our equation that's the inverse equation. Now let's check, we wanted to graph them, so let's double check that this works. Now inverse should be reflected across the line y equals x. So we're going to graph the original in here. Loading, loading, loading. Hello. Just because it's OGTs, we are not sitting around doing nothing, calculator. So we are going to type in our original equation, which was 2 times the square root of, now be careful, let's put it in parentheses, as it was, x minus 3. Because I want that quantity divided by 4, and that's still under the square root sign, and then I move over, and then I add 1 at the end. So that's my original equation, okay? And let's graph our inverse equation, which we said was the quantity x minus 1 squared plus 3. So let's graph those. They should be reflected across the line y equals x. So let's see what happens. Now I think my window is, I didn't change it back from other stuff, so let me change that. Let's hit zoom and number 6. That's normal viewing window. That looks a little better. I had it zoomed out really, really far. There's another problem. Okay, so here's my here's my graphs. Now what's the problem here? The blue was the original, okay? So if I reflect that across the line y equals x, I should only really have one side of that parabola. I think, okay, my equation was something squared, that means it's a parabola, but I can only have half of that parabola, right? So I need to kind of restrict the domain of this inverse function a little bit. Otherwise, you're going to expect other people to graph the parabola when that's not true, okay? So we need to just restrict this when we're going to look at, let's pause that, we're going to look at the range of both things. So if I had my f of x here, the range, where did it start? Where was its highest, or where was its lowest point? The range, the lowest point was 1. It didn't go past 1, right? So y has to be greater than or equal to 1. Now in my inverse equation, we talked about this a long time ago, the domain and range switch because x and y switches. So my domain is going to be restricted to x has to be greater than or equal to 1. Okay, so I'm going to look at the range of my blue, and I see that the lowest it goes is 1. So when I flip-flop that, I should really only have the positive side of my parabola when x is greater than or equal to 1. So let's kind of re-sketch that with the restricted domain. Just a quick sketch, since it does say to just sketch it. Alright, so we're going to have, in the blue, we'll be consistent with the calculator. The blue, this was my original square root function. With it restricted now, I'm going to be, this guy was worth 1. I'm going to say this is worth 1. So I'm going to start here and go up. And so I only have half of that parabola. I only have the positive side of that parabola. So we need to restrict our domain. If we're asking for the final equation, what's our equation of the inverse? I have this guy right here, x minus 1 squared plus 3. And I also need to include this restricted domain in my equation, or else it's considering the entire parabola to be the inverse, which is not the case. I can't reflect something if there was nothing there to reflect in the beginning. Okay? So this is problem 7-85. Make sure you show all of your work on the homework and ask your teacher questions if you still are unsure.